Hey everyone, and welcome to This Explainer. Today, we're taking concepts that might seem super abstract and turning them into a really fun, high-speed journey. We are going to track exactly how a single piece of data travels through the complex digital world, navigates invisible highways, and finally finds its perfectly organized home. If you've ever wondered what actually happens behind the scenes when you tap a screen or hit send, you are absolutely in the right place. Let's get started. Here is a quick look at our roadmap for today. We're going to cover the journey of data, highways and intersections, network maps and sizes, welcome to the database, unlocking the vault, and finally, speaking the database language.
Section 1. The journey of data, from raw facts to digital packages.
Okay, so a lot of people just throw around the words data and information like they're the exact same thing, but in the digital world, they're actually really different. Data is literally just raw facts and figures. If I walk up to you and just say 85, 90, 78, you'd probably be pretty confused. It means absolutely nothing on its own. But if we process that and I say, hey, these are the marks of 3 students, 85, 90, and 78, suddenly it makes perfect sense. That is information. Information is what we actually care about, and it's what we need to package up to send across a network. Right, so to get that information to travel efficiently, we actually break it down into these tiny, bite-sized units. We call them data packets. Think of it kind of like sending a physical letter in the mail. It's got 3 main parts. First up is the header. That's your envelope. It has the source and destination addresses so the network knows exactly where this packet is going. Then, right in the middle, you've got the payload. That is your actual message, the real content you care about. And finally, the trailer. This is basically a safety check at the very end to make sure nothing got messed up or damaged during the trip. So, address, message, check, header, payload, trailer. It's an incredibly efficient system.
Moving on to Section 2, Highways and Intersections, how your data physically travels.
Now, every single packet travels along what we call communication media. You can think of these as digital highways, and there are 2 main types. First, we have guided media. These are the physical cables you can actually touch. You've got twisted pair cables for your standard internet, coaxial cables for things like cable TV, and then those lightning-fast fiber optic cables. And a crazy fun fact here, those fiber optic cables actually send data across the ocean floor using actual pulses of light. On the flip side, we have unguided media. This is where your data is literally flying through the air on wireless electromagnetic waves. This is your home Wi-Fi, the 5G on your phone, or your Bluetooth headphones. It's totally wire-free and relies entirely on invisible frequencies.
So when your data reaches an intersection on these highways, it's going to run into networking devices. Let's compare a hub and a switch. Imagine you want to send a file to one specific computer in your lab. If your network uses a hub, well, a hub is basically a guy with a megaphone. It just blindly shouts your data to every single computer connected to it. As you can imagine, that causes a ton of unnecessary traffic. But a switch is way smarter. It's like a really good postman. It reads the specific address on your data packet's header and delivers it exclusively to the correct computer. It keeps everything fast, clean, and secure.
Okay, pop quiz time. Let's test your knowledge real quick. We just said switches connect devices within the same network. But what networking device acts like an entry and exit point, translating and connecting completely different networks together? Take a quick second to think about it. If you guessed a gateway, you nailed it. A gateway is super important because it translates between totally different types of networks. Think about it like having one person who only speaks English and another who only speaks Nepali. They literally cannot communicate without a translator. A gateway does that exact translation for computers, which is what allows your little data packet to leave your home network and actually enter the massive global internet.
Section 3, Network Maps and Sizes, exploring the layout of digital cities.
Networks come in all different sizes, tailored perfectly to whatever we need them to do. Starting at the very smallest, we have a PAN, or Personal Area Network. This is tiny, just a few meters around you, like connecting your phone to your wireless headphones. Step it up a notch, and you get a LAN, a Local Area Network. This is what you'd see connecting devices in a single room, a building, or your school's computer lab. Bigger than that is a MAN, a Metropolitan Area Network. That covers an entire city or a large town, kind of like a local cable TV network. And finally, the big one, the WAN, or Wide Area Network. This spans entire countries or even the whole globe. And the absolute best example of a WAN is, of course, the internet itself.
So, zooming around a WAN that massive, how does a packet actually find one specific device out of billions? Well, it uses an IP address. For a long time, we used IPv4. You've probably seen these, the addresses with numbers separated by dots. But here's the crazy part. IPv4 maxes out at about 4.3 billion devices, and honestly, we've outgrown it. That's why we're transitioning to IPv6. It uses a 128-bit system with numbers, letters, and colons, and it gives us a practically unlimited supply of unique addresses. Literally enough for every single smartphone, smart fridge, and self-driving car we'll ever build in our future cities.
Section 4. Welcome to the database, the vault where data lives.
Okay, I want you to imagine your school has 2,000 students. If every single student's information, their name, age, address, exam grades, was just written on loose pieces of paper and thrown into a massive, messy pile in the principal's office, can you imagine trying to find one specific student? It would take hours. It would be an absolute nightmare. So instead, the school stores everything in one highly organized digital filing system, and that is called a database. A database makes sure that massive amounts of related data are stored perfectly so you can easily search for, manage, and update things in just a fraction of a second.
To actually run this database, we use a piece of software called a DBMS, or Database Management System. Now, a standard DBMS is perfectly fine for small, simple stuff, usually just storing data in basic, isolated files. But for the massive, complex apps we use every day, we need an RDBMS, a Relational Database Management System. The magic word there is relational. An RDBMS doesn't just store data, it stores data in multiple tables and creates smart relationships between them, connecting everything together like an incredibly efficient web. MySQL and Oracle are perfect examples of this.
So, what's inside these tables? Well, data is perfectly structured into fields and records. This is super important to understand. A field is your vertical column, and it holds just a single type of information, like just age or just name. A record, on the other hand, is the horizontal row, and it holds the complete story. So while the name field might just say Ankit, the record tells us the whole picture. Ankit is ID 1, he's 18 years old, and he lives in Kathmandu. Basically, fields define what we want to know, and records are the actual complete answers.
Section 5. Unlocking the vault. How keys keep data accurate and connected.
When you have thousands of records, how do you make sure you don't accidentally mix up two students who have the exact same name? I mean, it happens all the time, right? Well, we lock down their identities using database keys. To keep everything perfectly accurate, we give every table a primary key. This is a rule that uniquely identifies every single row. The absolute best example is a student ID number. Even if you have 5 kids named Ram in your school, they're all going to have completely different student IDs. A primary key can never ever be a duplicate, and it can never be left empty. It guarantees that every single piece of data is completely distinct.
Quiz time again. Let's see if you're following the logic of the vault here. We know the primary key makes a record unique inside its own table, but which key allows us to connect two entirely different tables together, giving us that awesome relational power we talked about earlier? Take a moment and see if you know it.
And the answer is the foreign key. A foreign key is literally just a bridge. It's a field in one table that perfectly matches and references the primary key of a totally different table, and by doing that, it links the data. For instance, you might have a marks table that uses the student ID as a foreign key to link those exam grades back to the main students table. This ensures what we call referential integrity, which is just a fancy way of saying your database will never get confused about which grade belongs to which student.
Section 6. Speaking the database language. Taking command with SQL.
All right, so now we have this beautifully structured, highly relational vault. But how do we actually tell it what to do? We have to speak its language, and that language is SQL, which stands for Structured Query Language. SQL is basically divided into two main toolkits. First, you have Data Definition Language, or DDL. Think of these as your architects. These are the commands you use to actually build or destroy the physical structure of your tables. Second, you have Data Manipulation Language, or DML. These are your operators. You use these to add, view, or change the actual data inside those tables without messing up the structure itself.
Let's actually look at the commands in action. Need to make a brand new table? You use the create command. Ready to add a new student's record into it? Use insert. When you want to retrieve and view that data, you use select. But the coolest part is the where clause. It acts like an incredibly powerful filter. You can type select star from students where age is greater than 18, and bam, it instantly hands you only those specific records. If you need to fix a typo in someone's address, you use update. And if you want to get rid of a table entirely, you use drop. But a quick warning for exams in real life, drop permanently deletes the entire structure, so be super careful with that one.
From a completely raw fact, packed into a digital payload, sent flying across fiber optic oceans, and finally locked securely into a relational database vault, the journey of data is honestly just a modern marvel. You now understand the invisible highways and the exact SQL commands that control the whole shebang. So next time you tap send on your phone, remember that your data is fragmenting into packets and permanently storing itself in one of these vaults. Makes you wonder, what digital vault holds your data right now, and who exactly is holding the keys? Thanks so much for watching this explainer, and we will see you next time.